Hi everyone, welcome to Data Engineer Hub. Today we are going to solve a common Spark interview question, that is how to handle nested data. Handling nested data is an important skill for any data engineer, mainly who are working with complex data structures. In real world scenario, data won't be flat always. You might find like a JSON data or databases where fields contains fields. What is nested data? Nested data is a structure where data element contains other elements within them, creating a multi-level organization of information. Okay, so if you have a container, the container contains another container inside it. The same way, here the data was also present inside the data. Let me explain with an example. Here we have users data. So in users data, we have three fields: ID, info, and details. So here info and details are nested fields. Here info has two fields called name and age, and details has other two fields, location and job. And here again location is a nested field, and this has two fields, city and zip. Okay, so what was our task was we need to extract ID, name, age, city, zip code and job. These fields should be extracted from this data. How can we achieve that? Okay, so we have different approaches like using SQL queries, using getField with select, using withColumn, using selectExpr. Let's extract this data using these methods. Okay, before that we need to define schema for this structure to create a data frame. Okay, to define structure type and fields and the data types of the columns, we have functions to design a schema. So from pyspark.sql.types import struct type, struct field and string type. Here we have string type and integer types, right? So I was importing string type and integer type. Let's define schema, struct type. So we are trying to define schema for this data. Okay, so struct type. So coming to this user data has three fields, right? So we need to define three fields in this struct type. List of fields. So coming to the first field, struct field. What was the field? ID, right? ID. Coming to the next one, struct field, we have info. Next one, we have details. Okay, so what was the data type of the field? It was integer type, right? So we need to define as integer type. And there is other we can pass other parameter here. So whether we are considering this field as non-null field or null field, means that means we are allowing this column whether to insert null values or not. For now I was considering that we can insert null values in this column. Coming to info, it has two fields, right? So we need to define again the struct type. Struct type. Okay, in this we have two fields, right? Name and age. Struct field. What was the field name? Name. Next one, age. Okay, so what was the type of this name? It was string type, right? We need to mention string type. Age was integer type. We are allowing null values. Okay, done with ID and info fields, and coming to details, we have two fields, location and job. Okay, location and job. Coming to location, this location has other two fields, right? Again, we need to define the struct type. So this location has two fields, city and zip. We need to add those two fields. So finally, we have defined schema for the data frame. So let's start creating the data frame. Let's try to display the data frame. So my bad. Here we need to mention struct type. See, we got the data frame. So now the task was we need to extract the required columns as we mentioned before. Like we need to extract ID column, name column, age, city, zip, and job. Let's solve that using first approach. So let's create a temporary view so we can apply our queries on that view. Let's create temporary view. Display spark dot SQL. Okay, let's see first how this view looks. The same we got when we have displayed the same when we have displayed the data frame df. Okay, now let's extract the required fields from the users data. We need id, info dot name as name, info dot age as age, and from details, the details we have location we need city. And Trophy. Let's try to run. See, we got the required fields from the user's data, right? This is one way. Okay, coming to the next approach, using getField with select. Okay, so in SQL.functions we have a column function, and using that column function it has getField function, so we can make use of that. First, let me import that function. So let's give this data frame as tf using get. Okay, tf using getField. So data frame dot select, we are trying to select columns from this data frame. Okay, now let's try to display this using a data frame using getField. You see, we have extracted the data using this getField function. Okay, so now coming to the next approach, using withColumn. Okay, how can we achieve that? So let's create a new columns that we are going to extract from the data frame. Okay, column name, and using call function we're trying to extract. Let's try to display the data frame df using with column. So if you see, we got these extra fields too. So we need to drop these fields. See, now if you after dropping these two info and details, we got the expected data frame. Okay, coming to the last approach, using selectExpr. So the same way how we have given here in the beginning. So we are trying to give the same in the quotes. Okay, so let me copy this to make it simple. Okay, let's try to display this data frame. So we got the expected data frame. Okay, so you have learned in 4 different ways how to extract the data from the nested data. In the next session, we will discuss handling skewed data using salting technique. Thanks for watching. I hope you find this tutorial helpful. If you like the content, don't forget to like, share and subscribe for more data engineer content. Leave a comment if you have any questions or topics to cover. See you in the next video.